At the mole and mole conversions. The mole, 1 mole is equal to the molar mass of an element, or it's equal to 6.022 times 10 to the 23rd particles, as we like to call them, of atoms, molecules, formula units. So this is the unit, and this is the unit for molar mass, grams per mole. Let's go ahead and figure out how to do molar mass. So to find a molar mass, you must use your periodic table. Here is your periodic table. To find molar mass of, let's say, iron 4 oxide, the first thing we need to do is you must put it into a formula. So we know, since this is Roman numeral 4, that it's plus 4. Oxygen has an oxidation number of -2, so it's FeO2. Go back to nomenclature if you are having issues with that. Second, find each element on the periodic table and write down the atomic mass unit. This is the weight, basically, of the protons and neutrons in the nucleus. So find iron, and when you do, you see that it's 55.845. Oxygen is 15.999. What we have to do, though, is account for how many are in that formula. So we just have 1 iron, but we have 2 oxygen elements. So we take 15.999 times 2, gives you 31.998. We have to follow the significant figure rule here, and it's 87.843. So our molar mass will be written in grams per mole. This is interchangeable, so you can flop the mole and the gram. It's fine. So now, if we're going from grams to a mole, or mole to grams, this is how we do it. Let's say we have 500 grams of iron oxide, and that's equal to how many moles? First, you need to start with what you have. You have 500 grams. Second, decide where you're going to go. We're going to go to moles. Third, what do you need to complete this? Well, we know, since we have grams here, that we're going to need molar mass. So for this, we need molar mass, and we need the formula for iron 4 oxide. Remember, what we're trying to do is cancel out grams and get to moles. So let's work this problem out. We have 500 grams. 1 mole is equal to how many grams of this iron oxide? Well, we already figured this one out. Back here, remember, we said it was 87.843 grams of FeO2. So now we simply cancel out grams, and plug this into our calculator. What we're going to do is say 500.0 divided by 87.843. That equals 5.6919. What you also need to notice is we have to, at this point, follow the significant figure rules for multiplication. We have 1, 2, 3, 4 sig figs here, and we have 5 sig figs here. So we're going to go with this one. This answer is going to be 5.692 moles. So we were able to cancel out the grams. We're going to do another one and reverse the question. So let's say we have 1.5 moles of iron oxide. How many grams is that? So we need to cancel out moles. 1 mole is equal to 87.843 grams of this iron oxide, and we know that from the molar mass. Cancel out mole, and then we multiply this out, and we get 1.50 times 87.843. What you also need to note is you see this as a continual line. So this operation must go first. If we were to do this, then we would say divided by 1, but we all know what would happen there. So how many significant figures do we need? It looks like we need 3. So this answer is 131.7645. we're going to round this to 132 grams. What I want you to notice about these two answers is grams is usually a pretty decent size number, one that we're familiar with. It goes from maybe positive 2 to maybe 600 grams. And if you look at mole, the answer for moles are usually on the smaller area. In fact, they can be like 0.05. So that's just something to keep in mind as you're working these problems. All right, now we're going to go from formula units to the mole, or the mole to formula unit. So you're really looking again on what you have and what you need. So we are given 0.450 moles. We need to cancel out moles. And in order to do that, we have to use Avogadro's number. So we're going to do that. And we're going to say 1 mole is equal to 6.022 times 10 to the 23rd. What you're going to notice about these numbers, these formula units, these atoms, these molecules, is they're great, great, great big numbers because they're looking at the particles inside each element. All right, let's go ahead and calculate that out. 0.450 times 6.022 second E23, and we're going to get 2.7099 e to the 23rd. We need to follow 3 significant rules there. So we're going to say 2.71 times 10 to the 23rd. And this is formula units. Okay, now we're going to go backwards. We're going to go from, we're going to be given formula units, and we need to go to the mole. So we need to cancel out the formula unit. In order to do that, we're going to say 1 mole is equal to 6.22 times 10 to the 23rd atoms, or formula units, or molecules. So let's type this one in, and we're going to get 2.55 e to the 24th divided by 6.022 e to the 23rd. That's going to give us 4.234473597. But we only need 3 sig figs. So we're going to say 4.23 moles. Look at the difference between these two numbers. If you are getting a huge number for a mole, then you have done something wrong. So keep this in mind as you're working through the problems. The last problem we're going to do is one where we're going from formula units to gram. And if we look back at the very beginning one, we said, here's the mole, here's the molar mass, here's the atoms, molecules. We cannot get from the atoms or molecules to the grams without going through this mole. This mole is really important. We can't go from grams to molecules. So we're going to go from formula units to grams. You must go through the mole. So let's do a problem. I'll just make one up, but we'll still use iron 4 oxide since we already have the information about that. Let's go 200.0 grams is equal to how many molecules of iron 4 oxide? So 200 grams of iron oxide is equal to how many molecules? So we cannot go from grams directly to molecules. We have to go through the mole. So let's set this up. Let's say 200.0 grams. And we're given grams, we need to get to molecule, but right now we need to cancel out these grams. So we're going to say, that's over 1, that 1 mole is equal to 87.843 grams of this iron oxide. Cancel, cancel. Some of you like to stop right here and go ahead and calculate out. That will get you in all kinds of trouble. You need to do this as a complete problem. So now we need to cancel out the mole and get to molecules. So we do know 1 mole is equal to 6.22 times 10 to the 23rd. In this case, formula units. cancel out the mole, cancel out the mole. Very, very, very important. When you put this in your calculator, this has to be a solid line. And you have to do it in the order of operation. This and this go together, then you divide by this. So let's go ahead and do that. We're looking for formula units or molecules, so you can imagine this number might be high. Let's see, 200 times 6.022 second E23 divided by 87.843. And that's going to give us a pretty big number. We need 4 significant figures, so we're going to put 1.37108 blah 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 times 10 to the 24th. We're going to make it abide by the sig fig rule, so it's going to be 1.371 times 10 to the 24th formula units of iron 4 oxide. Hope this helps. Thanks.